Great. So today we are having four extreme and elite panelists from different places of the country working in different segments. And to start off with, I'll introduce myself. I'm Arvind. I'm a faculty here at Chemical Engineering. And I also head the Hyundai Hydrogen Hub at IIT Madras, so working on industrial R&D. So anyway, so I've been sitting in multiple panels, and one thing I've requested is that no presentations, and we'll discuss on most important problems that India is facing and not discuss on the generic things, and our panelists agreed to it. So let me start off with Ms. Neha from Omnium. Welcome, Neha. So we look forward to hearing from you, and also we have Mr. Rajesh, CGM from IOCL. We have Mr. Manish from Technip. Right, great. So I think already you see the variety of people here, and finally we have Professor Saroj Nayak. So he is the head of the Hydrogen Hub, Hydrogen Valley Innovation Cluster in Odisha. So among the four innovation clusters being formed, one in Odisha, the eastern part of India, he is leading that place. So the panel is arranged in this way. First, I'll have my panelists give a brief introduction about what they're doing and what their company is about for a few minutes. And then second round, we have a bunch of questions. From my side, I'll ask them. And then later, we will move on to, based on the discussion, however it evolves, we will move on to the next round of questions, and finally from the audience. So I'll start with Neha. Neha, on to you. So we have 3 minutes each.
Hi, everybody. Hello. Thank you, Professor. And excited to be here. Very happy to be a part of this esteemed panel. I'm Neha Khandelwal. I'm a product and program management head at Omnium. You've heard the name already. It was flashed on the screen when Anson was giving his very excited conversation about energy transition. Omnium is a company that designs, manufactures, and deploys green hydrogen electrolyzers. We make modular, scalable, sort of a cutting-edge PEM technology electrolyzers. We are a company headquartered in Silicon Valley. We have research centers as well as manufacturing plants in Chennai as well as Bangalore. We have an office here in CRDC. That's one of our research arms. We are also one of the most touted as the second clean tech company in US by Time Magazine in 2024. And in India, we are also as part of the SITE, which is the PLI scheme that Professor Lele spoke about, one of the awardees of that scheme in the manufacturing of green hydrogen electrolyzers. With that, looking forward to the discussion with the group here and looking forward to the questions from the group. Thank you, Arvind.
So my name is Saroj Nayak. I'm a professor at IIT Bhubaneswar, and as Professor Arvind mentioned, I'm heading one of the four valley that IIT Bhubaneswar is leading. That's what is the Hydrogen Valley Foundations. Before joining IIT Bhubaneswar, I think I'm probably newest, even including my young colleagues in working in India. Before I joined IIT Bhubaneswar about 9 years ago, I was a professor at Rensselaer, RPI in US. Before that, I was at Princeton. So I spent about 20 years in US. And then I came back, and now I'm in Bhubaneswar. So we'll be talking more about what we're doing, but our valley, as Professor Lele mentioned, their valley is looking at the chemical industry. Our valley is looking at the green steel and mining mobility. So these are the two sectors that our valley is focusing. Just so you know that we have been hearing some numbers. If you look at the CO2 emission, iron sector only accounts globally 7% of the total CO2 emissions. So this is one of the hard sector to decarbonize. That's one. In India, it actually tends to be 12%, not 7%, because we have some of the inefficient way of producing iron. And we are the second largest producer of the steel in the world. So we have a long way to go, so we'll catch on what we're trying to do and where it's heading in our view. Thank you.
Great, thank you, sir. Looking forward to listening to you. Sir, on to you.
Good evening, all. My name is Rajesh Bade. I am currently the Chief General Manager at Indian Oil Corporation Limited's Corporate Research Center at Faridabad. You all might be knowing about my company, Indian Oil Corporation Limited. It is the energy of India, fueling millions of vehicles, millions of households, and so many aircrafts on a daily basis. So our corporate R&D center is at Faridabad, and I look after the vertical of hydrogen. I have worked in various areas. I started my career with Indian Oil Corporation Limited only. I worked in the area of refinery process development, optimization, troubleshooting. Then there was a separate group was formed somewhere around 2012 because of this energy transition. Then I started looking after various alternative energy areas like hydrogen, biofuels. I also look after the petrochemicals vertical. So I will be talking about various initiatives and what is the role of hydrogen in decarbonization that I will cover in my comments. Thank you.
Rajesh, I think last time I filled petrol from your pump. Thank you. You are living in everyone's life, actually. It's around you.
Hi, good evening. I am Manish. I am from Technip Energies. Within 3 minutes, I will give a short introduction about my company, what we are doing in this hydrogen business. So I come from company named Technip Energies. We are in India for 50 plus years and around the globe for 60 plus years. So we are basically a technology and consulting firm. How the hydrogen, now specifically I will talk more mainly on the hydrogen, what we are doing in hydrogen. So we come with a background of hydrogen, 275 plus plants worldwide using our SMR technology. So we come with a gray hydrogen background. So that hydrogen molecule is not a new molecule for us. Then we also work on the blue hydrogen. There are various projects right now under construction using our technology, producing, which will be producing very soon, blue hydrogen. And now coming to green hydrogen, what we are doing. So we are the company in India, the first company in India to have executed a green hydrogen project of 2.6 megawatt using alkaline technology, 5 megawatt using PEM technology. These are the EPC projects we executed on single point responsibility towards our clients. And right now we are working on a project in India which is under execution. And the green hydrogen electrolyzer capacity here is going to be a 640 megawatt into 2. So this is the world's second largest green hydrogen plant that is under designing right now in India and will be in couple of years, it will be commissioned. So starting from a smallest capacity of 2.6, now in the design phase up to 1240 megawatt of electrolyzer. That's where our hydrogen journey is as of now.
1240, that's freaking large, sir. That's awesome. Thank you so much. So, we have like kind of a handful of questions, one of the things, I was listening to Dr. Ashish Lele in one of the previous meetings in his talk. He said about if we want to go for round-the-clock electricity. Today we are looking about when we move to sun and wind, Nansen also talked about it, we have to use storage. Without storage, there is no way we are going to have 24/7 by 365 energy supply, both short duration and long duration. And now the problem is not just for electricity, problem is also for hydrogen. If I have electrolyzer, 1240 megawatt of electrolyzer, we need to feed them with 24/7 by 365 renewable electricity. And I would like to just ask Neha about this. So Neha, like, you are from the hydrogen production industry, electrolyzer industry, like making hydrogen. And I also know that your business model is more of on the hydrogen side rather than the electrolyzer itself. You also have that business side, I believe, right? Electrolyzer side, yeah. So how would your customers and your company really looking at offering this round-the-clock electricity for the electrolyzers? Because they seem to be something that we have not really understood well. I don't know if you have the answer today, but we would definitely love to hear from you and understand what that means to the hydrogen community.
Right. So I think it's a very good question, Professor Arvind. When you talk about round-the-clock hydrogen, it's needed for the plants which are running continuously. Like Professor spoke about steel. Steel can never stop. It needs to run 24/7. Transition, I think, from Anson's conversation to Professor Lele's conversation, one thing is very clear, that we do need to move from gray to green, or gray to green to blue, whichever color you want to pick for the day, because it's critical, it's crucial, it's important to do. There is no planet B. When it comes to round-the-clock green hydrogen, there are multiple ways to look at this, right? And one needs a solution that's more flexible in its approach and nimble in its approach. The answer is not very straightforward that I can plug something in solar plants and it will produce solar power for 24/7. So practically you have sun for 8 hours a day. So if you want to have round the clock hydrogen, you basically would need to oversize the solar plant and oversize the electrolyzer. So one very simplistic way is to just have 3 times the solar park and 3 times the electrolyzer, get more hydrogen, store it, and use that in the times when there is no sun. That's very simple. The other way of looking at it is also then use battery storage, which is what you spoke about. The third one is also looking at pumped hydro, which is a very nascent technology that people are working on. Is again, using the sun at the time of the 8 hours per day, oversizing it, using the excess one into the pumped hydro storage, and then use it in the times when the sun is not there to basically then pump up the green hydrogen. Now, all of this is dependent on a solution which can be adaptable to different kinds of answers that are needed for different projects. Our technology basically addresses that question, that it's flexible and it's nimble in its approach to get tied into whichever of the solution that you would go forward to.
Great, Ek. I think specifically the last one, I think typically we won't consider as an option, but it's very great that you pull that option in. Maybe that has to go as a part of the policy making now. It's not just about oversizing or storing it in batteries, but it's also about there is another way of storage, right? Pumped hydro. That's really awesome. Thanks for sharing that thought. Now, I would like to just switch over to Rajesh and try to understand. So Rajesh, I think you mentioned about IOCL is living in everyone's life now, petrol, diesel, gas, whatever it is, we go there and get it done. Now, the mobility sector is one of the biggest polluting sectors, and we want to move to decarbonize it. And there are 2 schools of thoughts I'm hearing. One is on the battery side, EVs with batteries. And now the hydrogen is coming in, and I'm hearing thoughts about hydrogen. Any report I read, when it is written from the hydrogen perspective, it says batteries are bad. When it is written from the hydrogen battery perspective, it says hydrogen is bad. I'd like to hear some sort of reality in both might coexist or only one might exist, we do not know. But I'm sure from IOCL, you already have given a very clear thought, because you're going to live in our lives again in a different form, not just in the form of petrol and diesel. So what are your thoughts on it, Rajesh?
Before going to the mobility question, I will just like to appraise you that Indian Oil is one of the largest captive producer and consumer of hydrogen, because we use hydrogen in all our refineries to upgrade our fuel qualities, what we sell in the market as petrol and diesel, because you need to remove the impurities like sulfur, saturate the aromatics to satisfy the requirements of specifications. So we have about installed capacity of 0.7 million tons per annum of hydrogen in all our refineries. And that is basically used for captive consumption. As far as mobility is concerned, we were the first to start hydrogen experimentation way back in 2004. At that time, since CNG infrastructure was readily available, we thought that blending of some percentage of hydrogen to just gain an experience of using hydrogen for mobility application. So we started blending about 18 volume% of hydrogen in CNG, which is called as hydrogen blended CNG. Initially, it was blended separately, like we were procuring hydrogen separately and blending in CNG and then using in the vehicle as an automobile fuel. But that was quite a cumbersome process, because you need to have a separate infrastructure of CNG as well as separate infrastructure of hydrogen. So what we developed was a single-step compact reforming process, which converts only that portion of CNG to required percentage of hydrogen. And we installed one very big plant, a demonstration plant in one of the bus depots in Delhi, that is Rajghat bus depot. That project was done in association with Technip Energies, where we ran about 50 city buses daily for 6 months on the advice of Honorable Supreme Court. And we covered about 10 lakh kilometers in 6 months trials. And just by switching the fuel from CNG to hydrogen blended CNG with 18 volume% hydrogen, we were able to get BS6 emissions using BS4 engines. So that is one part of the story. As far as pure hydrogen mobility is concerned, we were the first to set up the high pressure hydrogen dispensing station in 2014 at our R&D campus, which is still operational. We currently are doing one very large project funded partly by Ministry of Petroleum and Natural Gas, wherein we have deployed about 15 hydrogen fuel cell buses in Delhi NCR region, out of which 11 buses are currently under operation in Delhi region, and 4 buses we have deployed at our Vadodara dispensing station, because Indian Oil has a very big hydrogen dispensing station at Vadodara also. So out of these 11 buses which are currently running in Delhi, we have almost covered about 50,000 kilometers with passengers, without passengers, in different climatic conditions in last 1 year. And our experience has been extremely good. There has been no safety incidents in running these buses. In fact, we are running one bus for Indian Army, which they are using for taking their officers and staff from one location to another location in Delhi. Similarly, we have given one bus to Indian Navy. They are also using for their officers. We also plan to give one bus to other defense forces like Indian Air Force and Coast Guard and other. And in fact, we are also planning to give 2 buses for Indian Parliament, which will be shortly commissioned, which will be run in Delhi for Parliament. As far as the question is concerned whether hydrogen fuel cell mobility is good or battery electric vehicles are good, see, both the technologies have their own advantages and disadvantages, and those are suited for specific mobility sector. As far as heavy duty mobility is concerned, if you go for a battery operated vehicles for long range applications, then the size of battery becomes too heavy. And that reduces the efficiency of your vehicle to such an extent that it doesn't become economically viable. So as far as heavy duty, long range mobility is concerned, like heavy duty buses, trucks, what we feel is hydrogen fuel cell mobility is the best answer. But as far as light duty mobility is concerned, like cars, there the battery can score better because it's basically a mileage accumulation is maximum 200 kilometers per day, and battery is relatively smaller, so we get a advantage of battery technology also. As far as the charging is considered, hydrogen refueling is just like your CNG refueling. It takes only 10 minutes to refuel your bus. And in a single refueling at permitted pressure of 350 bar, the bus can travel 300 kilometers as on date. If the government or the regulatory authorities approve 700 bar as a storage pressure, the same bus can cover almost 600 kilometers in single refueling of 10 minutes. But battery, as you know, even with fast charging, it will require minimum 30 minutes to 45 minutes. So depending upon the segment, you have to basically decide which technology you have to use. And one more advantage of using hydrogen fuel cell technology is basically the operational cost is, with current prices of hydrogen, even the operational costs are now at par with diesel or CNG vehicles. The only question is the initial capital cost of the vehicle. That is almost 2.5 to 3 times as compared to your conventional vehicles. So if we are able to bring down that cost, then the total cost of ownership of these vehicles will surely come at par with your conventional vehicles. Thank you.
Rajesh, just a quick thing on that. You talked about the present capex investment that has to be made on these vehicles are pretty high. Is it like any technology when we go for production in mass, the cost goes down? You think that also applies to it, or literally there is something inside which is quite expensive?
In fact, there is a very recent report from, I think, US, DOE, which says that by 2030, the total cost of ownership of these hydrogen fuel cell vehicles will be almost matching with your conventional vehicles. Okay. Because of the reduction in cost of these vehicles itself. Okay. Hydrogen will definitely match the operational parity with other fuels, because the hydrogen energy content is roughly about 2.4 times as compared to your conventional fuels, whether it is gasoline, diesel or CNG. And the advantage of fuel cell technology is that it has a fuel efficiency of almost 2 times as compared to your IC engine. So when you combine these two factors of 2.4 times multiplied by 2 times, so as long as your hydrogen price is below 4.8 times of your conventional fuel prices, it is going to be at the same price per kilometer.
Actually, this is quite encouraging. Thanks so much, Rajesh. This is awesome. So now, I think I just want to continue the same story out to Manish about, the ammonia or methanol. I mean, typically, those are one of the, those are two fuels which people are talking. One is on the feedstock side. Of course, we can go to fertilizers, like when you have to go to make green ammonia. And of course, it has its own barriers in terms of the economics, because fertilizer goes into the agriculture. That's a backbone of Indian economy. However, the ammonia as a fuel is being talked about either for marine segment and also for some other like large production, like with high gas turbines, ammonia-based gas turbines. Typically, the ammonia is considered as a kind of toxic gas even today. Even ppm of leak is kind of not acceptable. However, on one side, we are hearing the stories like this ammonia-based gas turbines with sufficient trapping of NOx or unreacted ammonia, it can be made quite effective. So with your experience in the hydrogen and ammonia industry, where do you see the offtake of ammonia would be? Is it going to be predominantly on the export market, but also, or is it or is it going to be for the markets in the marine segment and other places?
I will say, I think Dr. Lele has made our task quite simple about explaining what's the hydrogen economy and where it stands. It's very clear that yes, hydrogen is the element of probably the future, the only thing how we make it more viable, more economical. So ammonia is one of the route. Let's say considering if we talk about the fertilizer sector. So fertilizer sector, any one of us, do we know how much a bag of urea costs today in the market, in the open area market? Do we have any idea? Anyone? Okay, even if my grandparents were with the farming background, I don't know. But when I search on the internet, the cost of a bag of urea, the farmer pays about 300 to 350 rupees per bag of urea, which is about, I think, 20-25 kgs of urea. And how much it costs to produce this bag of urea? As per government information, it requires about 2,500 rupees to produce that bag urea. So it means, as per government data, government is paying 60,000 crore subsidy on producing fertilizers. So this is a sector where the already so much of subsidy is going into outflow is there. It's difficult to think about that. Okay, this is the sector it's going to adopt to the feedstock, which is substantially costlier than the current feedstock. So, okay, there may be few experiment happening here and there that, okay, you use 1%, 2% of your existing feedstock with green ammonia, etc. That may happen on the pilot scale basis. But yes, currently what we are working on, one of the project is converting the existing gray ammonia plant into the 100% green ammonia plant. And as it is said, we have to search for where is the market, where are the buyers to pay this premium for this product as of now. So one of the, yes, hydrogen, why ammonia? Why people think about ammonia or methanol? Because ammonia is considered as a carrier for hydrogen. The countries which cannot produce hydrogen, so for green hydrogen, what is the input? It's a power, solar and wind. So if we talk about the countries like European Union, Japan, Korea, they don't have that much of the renewable power. They may be having a nuclear power, but apart from that, the wind, solar is very limited. But fortunately for countries like India, where the RE power is very cheaper, the construction cost is very low, this is the right place where we can set up the green hydrogen, green ammonia plant. And we can produce at a much more economical cost this thing and export to be the supplier for the rest of the world. So that is where, so most of the project, there are several clients we are discussing, we are interacting with. They plan to set up a green ammonia plants, and they will be basically right now it's the export market. So green ammonia, it's for the export market right now. There are clients who are looking up, as Sir said that, Dr. Lele said, Paradip, Tuticorin, this could be the port which will be falling on the grid corridor. So there are few clients who are looking after setting up a green methanol plants. For green methanol, basically the challenge comes how you secure the biogenic CO2 source. Because if it is not a biogenic CO2, you won't get that green methanol tag for selling that into the European market. So over a period, as economy of scale, that's what the question you ask to Doc. So that will basically bring down the cost as you grow on the economy. Because in 2014, there was a report saying that solar PV is one of the costliest way for reducing the carbon footprint. That was a 2014 report by one of the world leading agency. And today we are setting up the solar PV on our rooftop. It's at if you can go into the farmland, he is running pump with solar. So that way we expect over a period, this price of electrolyzer will come down, and the green hydrogen economy will also, there will be also more consumers within India.
Great. Thank you, sir. Actually, to see, like, essentially, as of today, export market is what we need to target, right? So that's, I mean, and then eventually we'll also get into the internal consumption.
For ammonia, yes, it's for export market.
Okay.
But for internal consumption, we cannot always say, because it's also for reducing our CO2 footprint.
Okay.
So like companies like IOCL, they are the one, we did the HCNJ project together. So that is a blending of hydrogen into the natural gas. It's one of the best way you can run your buses, CNG buses, without any modification. Because if you talk about hydrogen bus, it's a altogether total new configuration of a bus. You have so many natural gas buses, CNG buses across India. You just blend it with hydrogen. You get no modifications required in the buses. Emissions is coming down. That is a step-by-step approach. That is what is required, basically.
Yeah, sure, sure. Thank you so much, sir. Actually, we have discussed about two downstream activities after the hydrogen is being produced, one on mobility and the other one, of course, fertilizer and possibly other applications. Now, I'd like to go into this very volatile area, which is steel, actually. So Saroj, sir, I've been following some of the activities going on in the steel segment, and where we are talking about replacing the blast furnace, blast arc furnaces with the DRI process. I've also noticed that we are producing somewhere around 120 million metric tons today, and we are anticipating to go to 200 million metric tons. I would like to understand from you, your valley is setting up all these things in Odisha. I'd like to understand, what is the portion of this new expansion that India is considering to have as a DRI process? And if not, what are the impediments that is stopping India or elsewhere in the world from moving from the conventional BF-BOF technology into DRI, sir?
Right. So as you said, we have heard hydrogen in many other sectors, but the steel sector is probably where not many people be familiar that, you know, in terms of also the possibility, as you said, because we have heard about the blast furnace and other things, and also whether it's commercially viable, right? So a few things, let's put the numbers and perspective. If you look at some of the sectors like mobility, you have some options, right? So you can electrify, you can use hydrogen, fuel cell, and so on. As you have heard, small vehicles, maybe if the battery is commercially viable, but if you look at the long range, even shipping, for example, I mean, you can't use the battery. But if you look at the iron industry, and it's a very simple thing, say, what do you do in iron industry? You have iron oxide, and just remove the oxygen, and you get iron. Currently, we are using carbon. And the problem is that it's coming out as a CO2. When you use hydrogen, water will come out. So it's very simple. But it's simpler than, when you go out, and the problem or the challenge is this hydrogen cost. So as we have heard from Dr. Lele and others, the hydrogen is about $5, let's say, give or take. And can you make steel, and that's still commercially viable? So as you said, right now in India, we are, in fact, if you look at the chart, it's exponentially growing the steel production. And I think in the next 5 years, we are going to be double. And we are still, per capita consumption is much lower compared to the developed countries. So which means it's going to be triple when you are going to develop. And the question is whether we are going to decarbonize or we are going to go as business as usual. So as you have seen, and as a physicist, I can tell you there are different kinds of transitions. Phase transition we talk about, and you know very well. So in my opinion, and what we have done analysis, right, this is not going to happen as a very rapid transition from blast furnace to DRI, green hydrogen-based DRI. In fact, India, as you speak, is leading in terms of the DRI. So if you look at the eastern belt, for example, Odisha, Chhattisgarh, Jharkhand, there are a lot of DRI industry, but they're all based on coal. We have JSPL, again, is another plant, is based on natural gas, but India doesn't have the natural gas as, compared to, let's say, Canada or, for example, in US and other countries. So there are a few things that our analysis shows, and so that you know that this technology that I just described, the simple technology I told that, going from iron oxide to iron with hydrogen, one of the most celebrated and demonstrated plant is in Sweden. It's called a hybrid plant. They have already shown it works. The quality of the steel comes out is actually superior, but the cost is a factor. And so in fact, our valley, as we speak, we have the technical partner is the founding CEO of the hybrid plant. So that makes life much easier because, as you know, some of the industry, if you want to go and buy the industry, you have to spend hundreds of millions. And so we have been very fortunate that we have that. This will be when you establish.
Sorry for that, just a quick thing, sir.
Yeah,
when
yeah.
you partner with them, you also do the technology validation of that?
Yes. So I think that's what, I think the very good questions. In India, as you speak, as I said, we have tons of DRI. In fact, we are the world leader in terms of DRI, but based on coal. We have not a single green hydrogen DRI. So if we establish and stay tuned in next 2 to 3 years, this will be the first prototype, pilot, and semi-commercializations. In fact, in addition to the value that we have got from the DST, our consortium, which is industry-led by Matrix Genshaw, we got also 350 crore projects from the Ministry of Steel. So this is another project other than the DRI. That is going to be synchronized with the value that we got from DST because, as you said, we don't know in terms of the commercializations, in terms of the process optimization with the iron ore based in India. So so it's getting a little technical. I just tell you, the iron ore that we get in Sweden, for example, is about 72% of iron content. Typical iron ore content in India is 62%. So whole reactions process, everything has to be optimized. You can't do a plant and then you optimize there, and you know the industries. So this is where work is going to focused, optimize, and then scale up to the scale. So, and I will just use 1 minute. It's not just the decarbonization, right? So obviously then you ask the question, is it going to be price competitive? So if you look at the CBAM, which is the tax that the Europe is going to put, and we export a lot of steel to Europe. So they are going to put 40% tax. So our analysis shows actually this company will be better off that they do decarbonize here for those markets than paying tax there. So that's one thing. The second thing is that if you look at the economy, it's in Odisha and other, Odisha is one of the states in India which has a revenue surplus. You have heard many states that are going kind of different directions. But thanks to this is because of about 50% of revenue comes from the mining, and iron is the leading one. So the question we ask is not also decarbonizations. Are you going to be the Detroit of tomorrow where the EV takes over and then you fall behind? Or you are going to prepare the industry now for the next 5 years? Because like it or not, we have seen in the solar, it's going to come. Whether you are going to lead and or borrow the technology, it's up to you.
Okay. Great, sir. I think, thanks for that. I think that is going to lead me to another question, actually. So this is slightly philosophical. We'll take like 1 minute each to answer that. So, if we say India leading R&D, I would just only put ISRO in terms of like visibly like taking a big space. Or some other places where India has taken it is cricket, Compared to the rest of the world, I think we are one of the big leaders. Somewhere we need to learn the strategies. Then if you take the, UPI, you make the payment, we are the world leaders, seriously leaders. When I say leaders, not like piggybacking onto someone and then be in the tailpipe of the entire stream. And when it comes to solar, the world has lost the entire manufacturing thing to China, honestly. I think let's confess to that. I'm an academic. I think I don't have to really worry about anything and I can speak the truth here. Similarly, but hydrogen space, I think we have woken up quite well. Batteries we have lost already also, I believe, in terms of technology. Trying to do makeup. What is that India has to do in order to, either it's an R&D or a policy perspective, it's for all panelists, to remain the best in the world. ISRO, when it started, already NASA was really big. But then ISRO started quite late, and now we are one of the leaders in the world. Similarly, what is the strategy that you believe from your experience and perspective that India has to do in order to be leader in the hydrogen? Sir, I'll start with you, and then we'll go this way.
Yeah, actually, what you said is right. If you see the total renewable energy or energy transition sector, not renewable energy transition sector, this is going to work on the collaborative basis. It's not the one company who is going to take the lead. So you are saying you are going to see a lot of joint ventures coming up with the institution, R&D institution, or the startups, and the companies, the established company doing the JVs with them. Like we are also setting up a R&D facility at IIT Madras campus. That's one of the way we are trying to see how we can be the getting into the innovative things, innovate in India for the rest of the world. The other point is, for at least for the green hydrogen, there are many companies in India who are planning to set up a electrolyzer plants in India. There are companies in India who are planning to set up the balance of facility for electrolyzer part. Like our company, we have also formed a joint venture with a Belgium company, and we have launched a product, 100 megawatt electrolyzer. So that way we plan to achieve the economy of scale to bring down the cost of electrolyzer. And once the electrolyzer cost comes down, we expect in future the cost of hydrogen will also come down. That's why not only us, there are many companies in India who are trying to set up the electrolyzer manufacturing or ancillary facilities produced, manufactured in India, which can be exported outside the world. And one of the key, yes, as we want to grow up, each time we say that our per capita CO2, per capita steel consumption is lesser than US, etc. But probably we will develop like the way of India. We will not be hitting those upper mark, benchmark while we develop, our company moves into the development phase. Mostly likely we expect we should be in the sustainable development path that we will follow.
Great, sir. The JV, I like that like collaborative work. Sir, Deepa here. Take a minute.
In my opinion, in fact, hydrogen cannot remain as a fuel for the future. It has to become the fuel of the present, otherwise the decarbonization is impossible to achieve. And this can only be achieved through joint research and development, demonstration, deployment, and scale up at a speed. And National Green Hydrogen Mission, which has been recently launched, has given a launch pad for this, and we are quite confident that we will be able to achieve this propagation of green hydrogen in all sectors of economy.
So that's going to be a tagline actually, sir. Hydrogen is not a fuel for future, it's a fuel for today. Yeah, thank you so much, Saroj sir.
So in general, I would say hydrogen or in any other sectors, I think one of the things that the country should have a policy to set the bar very high. Obviously, we have to be realistic in academics or industry. We have to support, but don't support forever. So in a sense, encourage the excellence, don't protect the mediocre.
Oh, we're getting another tagline today. Oh, awesome. Awesome, sir. Neha, to you.
I was listening to everybody and I came up with a lot of themes that I can consolidate together. Professor Lele beautifully touched upon the new applications of where green hydrogen can be used as opposed to the conventional known names of steel, cement, refineries, transportation. Esteemed panelists here has touched about mobility, touched about scalability, and I think what's important to note that every industry, whether it is steel or it is anyone, needs that learning cycle. They need to start with a pilot project to learn how to use this beast, which is green, what adaptations they need to do in their own processes to make it most viable for themselves. We also talked about technologies like, where should we stand in this race? You talked about having manufacturing in India. We already have a gigafactory in Bangalore. It's not future, it's today. We make cutting edge electrolyzers. We do our research in IIT Madras campus. The electrolyzer is modular in its nature. And why it's important is because you want to start small, but you want to be able to scale very fast when you are proven the concept. And I would invite all the students here, if you want to come and see our factory, please go ahead and send a request. I would love you to see how we could scale up vertically and horizontally. It's like a Lego board. You start with a piece and you keep joining the pieces, and you can go from a megawatt to gigawatt, which is what is needed for large applications. We are not too far away from viability. Japan just announced $19 billion subsidy for all import as well as domestic markets for hydrogen pricing subsidy differential. So if there is a delta, if you say $4 versus a $2, they're ready to pay for it. And that's what's going to sort of make it viable today for a lot of applications for export market, as he spoke about, but also domestically. And that's my last point, just to touch upon to that. All you guys sitting here, I mean, we all as a country are known for being the talented, skilled workforce. But added to that is we are also a ground for a very competitive renewable power. We are also a ground for a very, very competitive manufacturing. We are also a ground for a very, very competitive EPC. So just take all these factors together. It's our race to lose if we have to. We can win if we put the right steps, and I think government has the intention to do that. The industry, the academia, the policies also need to play a role together. But I would just end to say this is our race to lose. We were already at an advantageous point where we are starting right now, and that should just make us leap forward in this race.
Great, thank you so much, Neha. You know, there are a few things that I want to see, and then wrap this whole thing up in next 30 seconds. Work together, work towards excellence, has mentioned, and work in future, and that's already happening, right, with Omnium. So I think hydrogen-wise, I think we are seriously in a big race, and collaborative work is extremely important. And once I had a discussion with Dr. Lely and also with you, Dr. Saroj, how to work together in all this space. We need to create some sort of forum, not as a professional societies, but as an informal societies, in order to really discuss, in order to really see something, make something meaningful. I mean, sometimes we don't have to really make a financial thing out at the very end. Developing technology and remaining core of expert in that technology is extremely important. There is no such thing called you wake up the next day and then you have a technology output. I mean, from academia, I can strongly say that any technology development needs 5 to 7 years minimum from the time we deliver anything. Any proposal calls you see from the government, any ask from anyone today, we see, you have great experience, sir, always says that we need the product in 1 year. So, somewhere I feel like this informal things will enable us sit together and try to see, let's work consistently for next 5 to 7 years and make a very strong technological ecosystem in the country, which will eventually make this country the leader in the hydrogen ecosystem. And with that, I'd like to thank my elite panelists. Honestly, this is seriously a very intense discussion. Would like to continue for another hour. So thank you so much, sirs and madam. Thanks so much for your time. And thanks everyone for staying back until 7 and plus p.m. Thank you. Thanks everyone.